Up to now, all of the factoring we've done with trinomials has been when we've had a leading coefficient of 1. That means when a is equal to 1. So we just had x squared plus something times x plus a constant. And we were able to factor those using our box problems. This is the first video, and this is the first day where we're going to start looking at, well, what do we do if there's something other than 1 here? So as an example, what if there's a 3x squared instead of just an x squared? So we have to again make sure we understand that all of these trinomials need to be in standard form first. We need to be able to do box problems still, and we're also going to be bringing back factoring a GCF, because that's the key to this. The key to this is doing both GCF and box problems in the same thing, and you know you have to look for that as soon as you see that you have something in front of your x squared, a number in front of your x squared. That means first and foremost look for a greatest common factor. You circle your addition or subtraction signs, you find all of your factors. This is just 3 and x times x. If you go off to the side and you factor tree 12, 6 times 2, that's 2 times 3 times 2, so you know you have 2 times 2 times 3, and an x here. We already factor treed 12, so it's 2 times 2 times 3. And now again, we're looking at what is the common factor. They all share 3, so I know I pull the 3 out. That's all they all share. I have x's here and here, but not in the third. I have 2's in the second and third, but not the first. So now it's about what's left over. X squared. 2 times 2 is 4. X. 2 times 2 is 4. So it's 3 times x squared. It's an addition problem. 4x. Addition. 4. That's what we did in the first day of factoring. But we can't always stop there. Now that we know what to do when we have standard form with leading coefficient of 1, I now have to do a box problem. So I started with a greatest common factor, and now I'm going to do a box problem. So 4 is my constant, that goes on top. 4 is also my coefficient of x, my b, that goes on the bottom. What multiplies to 4 and adds to 4? Well, that's 2 and 2. They're both positive, so this one piece here factors to x plus 2 times x plus 2. But you cannot forget this 3. That's my final answer. Okay. Similar to when I factor treed 12 over here. That was 6 times 2. 6 can be factored again into 2 times 3. But I'm not done until I bring everything down, because all of this has to multiply back up to 12. Same concept here. All of this has to multiply back up to 3x squared plus 12x plus 12. If I don't bring the 3 down, it doesn't do that. If I don't bring this 2 down, it just multiplies to 6. So you have to bring all of the factors down. Looking at the next example, it's the same concept, because this is x to the third. It is a 1 in front of it, but it's not x squared. That's the other key to recognizing that I've got to look for a GCF first. So this is x times x times x. This is 2x times x. This is 3 times 5 times x. And I find the common factor. The only thing they all share is an x. That gets pulled out. X times x is left over. 2 times x is left over, 3 times 5 is left over. So it's x squared, it's a subtraction problem, I bring that down, 2x, subtract, 15. That's my greatest common factor. Factoring, now it's the box problem factoring. So I check to see what multiplies to negative 15, that's why these signs are so important, and adds to negative 2. If I need to do the math off on the side, that's 1 times 15, where 1's negative, 1 times 15, where 15's negative. 2 doesn't work, 3 does, negative 3 times 5, or 3 times negative 5. Only one of those combinations adds to negative 2. That's this one. So it's a negative 5 and a positive 3 in either order. This expression now factors to x minus 5 and x plus 3, but my answer has to include the GCF as well. Then I'm done. Again, factor completely is going to be our directions, and the one major difference right now, this is not in standard form yet. So you have to make sure it's in standard form before you start looking at any information. X squared has to be first. It's a positive 6x squared. That gets written first. Now my x term, minus 18x. And then my constant term, it's a negative 24, so it's minus 24. So first and foremost, standard form. Now, my x squared has a number in front of it. It's a GCF problem. So I factor tree. 6, that's 2 times 3, and x squared is x times x. 18. If I have to go somewhere else and factor, I will. 3 times 6. 6 is 2 times 3, but just like with this other factoring that we're just learning now, I can't forget that 3. I have to bring that down. So 18 is 2 times 3 times 3 with an x. 24, that's 4 times 6, which is 2 times 2 times 2 times 3. So this is 2 times 2 times 2 times 3. And I look for the common factor. They all share a 2, 2, 2. They all share a 3. Oops, that's a 2. That's the only things they all share, so I bring my GCF out. It's a 6. There's x squared left here. X squared goes here. Subtraction, subtraction. 3 times x left here, so 3x. Subtract. 2 times 2 is 4. That goes here. Now I look inside the parentheses. What's left is an x squared trinomial. That's a box problem. Negative 4, negative 3. So what multiplies to negative 4? Well, negative 1 and 4, 1 and negative 4. 2 and negative 2. Which one of these adds to negative 3? That's this middle one here. So it's a 1 and a negative 4. X plus 1, x minus 4, bring the GCF down. So again, last problem. I have a number in front of my x squared. My constant is 0. I could still factor tree or factor this with the box problem. But because there's a number in front of x squared, I look here first. 8 is 2 times 2 times 2. X squared is x times x. 8 is still 2 times 2 times 2 with 1x. So what's in common? 2, 2, 2, x, and that's it. 2 times 2 is 4, times 2 is 8. X is my common factor. X is left over here. Nothing's left over here, so we've seen this a few times already now. There is still technically a number here. There's a 1, and we have to include that. This doesn't become x minus 0 or just x. It has to be x minus 1.